Hi, everybody. I'm sorry I can't be there. State Robotics Championship. Hopefully, everything's going well for you, and hopefully you will all enjoy your spring break. So today we have a quick area review. So you may want to have a calculator handy just to help you out if you don't have one already. So I put some basic formulas up in here. You may want to add on the trapezoid formula if you wanted to do that. But let's just kind of walk through some basic shapes, and then I'll talk you through how to do regular polygons. It's pretty easy. I think you'll all do pretty well at it. Okay, so first of all, shape A, rectangle. If you look up here, there's a base times height as well as a length times width. It doesn't really matter which one you use. That's up to you. Okay, so we're just going to go fill in our formula. We have 6 times 8. We put that in our brain or our calculator, and we end up with 48. And since we do have units, we're going to put inches squared. If you don't have units, you don't put anything. Okay, now let's talk about this guy right over here. So what you see right there, that is the slant height. And that is not the height. When you look up above and it says base and height, that's not the height they mean. The height has to be perpendicular to the two sides. So we already see this one's marked as being perpendicular. This one is also up here at the top. It is going to be perpendicular as well. So we're looking for a height that's perpendicular to the base. So when we do area on this one, we're going to have 6 times 5, and that's 30. And since we see inches, we'll put the meters squared. Okay, so again, we need 1/2 base times height. The height has to be the perpendicular. It can't be the slanted height. Okay, so area equals 1/2 base times height. And it doesn't really matter with a right triangle which one of those you choose. And that comes out to be 30. And since we do see units, we're going to put them on our answer. Okay, moving down here to the end, we got another triangle. Again, that height has to be that perpendicular height. It cannot be one of these two sides. Those are slanted. So area equals 1/2 4 times 6. And since we do see units, we are actually going to put those in our problem. All right, so our last one in this group is the circle. Again, your formula up here, pi r squared, where r is the radius. Typically with these problems, we will leave an exact answer. So we have area equals pi 14 squared. Exact answer means it does not have a decimal in it. That would mean a fraction or an answer that has pi or an answer that has a radical. So I'm going to put 14 squared in my calculator. I get 196. I put the pi on the end. There are units, so I put those units. Okay, so hopefully all of those made sense. Those were all from middle school math, so it's just a quick review. The reason we're doing a review on this is we're about ready to do volume, and a lot of the bases that we'll be talking about, I'll tell you to do the base times the height. And a lot of the bases we'll be looking at will be circles and triangles and rectangles and squares. So it's important to understand how to calculate the area of the base. All right, so our last one that we have for today is this one. So this formula can be written as 1/2 NSA if you like, or it can be written as NSA divided by 2. All right, N is going to be the number of sides of the figure, so you just count those. S is going to be the length of a side. Again, you should be able to find that pretty easily. We'll talk about it, what if you can't. And then A is going to be something new, and that's called the apothem. That is a rectangle, that is a segment that's going to go from the center straight out to a side at a right angle. So let's go to the other side. Here are some definitions for you. First of all, this stuff that we're doing applies only to regular polygons. Regular polygons mean that all the sides are equal and all of the angles are equal. That's what makes it regular. Now, the apothem, that is a line segment from the center of the regular polygon to the midpoint of the other side. It has to be perpendicular. So an apothem is a perpendicular distance from the side out to the center. Okay, so let's take a look at this first nice little hexagon that we have here on our paper. All right, so how are you going to find your angles? So since this is regular, we are able to envision it as part of a circle right there. Okay, so when we find this, we want to think about this as being a whole group of central angles. And if you look at the way this is divided, we have 6 central angles. So we're going to take 360 and divide by 6, and that's going to give us 60 degrees. So that means that the angle that is right here, all of them, because they're all the same, because it's regular, is 60 degrees. So that's what that means. Now, you may be saying to yourself, okay, but how am I going to use that this way? So we're going to drop our apothem straight down to the side, and it will form a right triangle. The angle up here is now 30 degrees. Using what you know about the sum of the angles in a triangle, this angle must be 60 degrees. Okay, now we know the side length for this shape is 16, which means this is 8 and this is 8. So using our special right triangles, we need to find the length of the apothem. This is the short leg, that's the long leg, which means that this side is 8 times the square root of 3. Okay, let's put all that together over here on the side. So my apothem is 8 times the square root of 3 using special right triangles. The length of an entire side of this shape is 16. I'm getting that from right there in the picture. And then I know that the number of sides is 6 because I can just count that. So I'm going to slide over a little bit. So that means the area is going to be equal to N S A all over 2. Now, since I have nice numbers and I have our square root of 3, I'm going to put the 6, the 16, the 8, and then the divided by 2 in my calculator. And that is going to give me 384 square roots of 3. There are no units on this, so I do not put any units. But that is the area of your regular polygon when you have a 60-degree angle, which forms a 30, 60, 90. Okay, let's try one where it doesn't form a nice 30, 60, 90. Okay, so again, we think about all these triangles. You say to yourself, okay, there's 1, 2, 3, 4, 5, 6, 7, 8 triangles. Okay, so I'm going to take 360 and I'm going to divide it by 8, and that is going to give me 45 degrees. So that means that every single one of the angles that are in here is 45 degrees. Okay, so just like we did last time, we're going to draw ourselves a line that goes from the center straight to the side. That's our apothem. Now I'm going to make this triangle a little bit bigger. So this is the same triangle that I'm dealing with right here. I'm just redrawing it a little bit larger on the paper, just so that I'm not quite as squished. Okay. There's my right angle. There's my apothem. Okay, so let's fill in what we know about this triangle. So first of all, I knew this was 45, the whole angle is 45 degrees. So I'm going to divide that by 2, just like I did up above. So this comes out to be a 22.5 degree angle. And then I'm also going to find this one because remember we know the sum of the angles in the triangle. So that's 67.5. Now other things we know this whole side is 10. So that's 5 and that's 5. Now unfortunately this is not a 30, 60, 90 triangle. So we're going to have to use trigonometry to find A. All right, so again, we imagine ourselves right here in the problem. This is the side that is adjacent to us, and this is the side that is opposite us. So that's a tangent problem. So we're going to do tangent of the angle where we're standing. Make sure the mode of your calculator is on degrees. The side opposite is A, and the side adjacent is 5. I'm going to multiply this 5 to the other side. And this is going to help me find A. Now this time I don't have a nice little radical or something like that to deal with. So I'm going to end up with a decimal for my apothem. So when I put all this in my calculator in the correct mode, I come out with 12.1 for my apothem. So let's take a look at what our other pieces are. So we know that the length of a side is 10. We're getting that from right there in the picture. And we know that the number of sides is 8. So let's put all of this together into our formula for the area. So the area equals 12.1 times 10 times 8 divided by 2. This time it's going to be a decimal answer because I'm putting in decimals, 12.1. So my area comes out to be 482.8. Again, there are no units, so I don't put any units in the problem. Okay, let's go to our last little triangle here. Now, I know there's some other ways to do this. I know there's a couple of you saying, well, I can do it this way or I can do it this way. Remember, this is a regular triangle. So we're just going to practice it this kind of weird way we've been doing. Let's put a center on it. Let's draw our triangles. Okay, so first thing I'm going to do is figure out how big each of the angles are in the center. So there are 1, 2, 3 triangles. So 360 divided by 3 is going to be 120 degrees. So that means that every single one of those central angles is 120 degrees. Okay, now let's drop our apothem straight down. Your apothem is a line segment that forms a right angle with the side. So if this is 120, that makes this 60. Remember, that's 90, so that's 30. Oh, look, it's a 30, 60, 90 triangle. We get to use our rules on that. Okay, so we know this side is 20, so this is 10, and that's 10. Okay, looking at this 30, 60, 90 triangle, that's the long leg, and that's the short leg. So to get from here to here, I have to divide by square root of 3. So this segment that's right there, the apothem, is going to be 10 divided by square root of 3, which when rationalized becomes 10 square roots of 3 over 3. So my apothem is either 10 over the square root of 3, or it's 10 square roots of 3 over 3. I know that the length of the side is 20. That's coming from right here. And I know the number of sides is 3. So let's use our new formula. So area equals N S A. Okay, now since there's a radical 3 in this, let's talk about what goes in the calculator. The 3, the 20, the 10, the divided by 3, and the divided by 2 will all go in your calculator. And when you do that, you're going to end up with 100 square roots of 3. Now, this does have units on it, so I'm going to say centimeters squared. Now, if you happen to turn this to a decimal, it'd be 173.2 centimeters squared. Now, if you did this another way, which is perfectly fine, okay, we were just practicing trying to use a new formula, you'll end up with exactly the same answer. All right, I hope you all enjoy your spring break. Your homework for today is to do a delta math assignment. So there's a delta math assignment with regular polygons. It should take about 30 minutes. And when you're done with it, that's it. There is no spring break homework. Now, if some of you decide that you want to spend some time catching up on some old assignments, that's perfectly fine. Love it if you did that. But again, I am not giving you any homework.